Hi all, this is Mr. Yeager for chemistry. I was about to say physics. For chemistry. And we are looking at acidic compound formula writing and naming, so continuing this nomenclature unit. And so acids are another type of compound. They're very closely related with, I would say more closely related with ionic, but I mean, I don't want to say that because it could kind of have some covalent properties with it some. But they have their own unique naming, basically procedures, way to kind of go with it. So anyway, we're going to get going with it. Again, this presentation was made by another chemistry teacher of my team, and I appreciate, again, everything they do. So here we go. All right, so an acid itself is an ionic compound. Sorry. All right, it is an ionic compound. And it's an ionic compound that contains hydrogen as the cation, okay? And so that's your kind of your clear, immediate clue that this is an acid compound, is it has hydrogen. Hydrogen is the first element in it. Now, if hydrogen is the second element in the compound, in the chemical formula, it's not an acid, okay? At least the way we are going to be doing it. So it has to start with the acid, with the hydrogen. It does act as a cation. It is H+, all right? And these acids are always aqueous, which means that they have been dissolved into water, and therefore they're in a solution form, is really what aqueous means, is a water solution. Okay? Here's some general, obviously, common household acids that you have around. I mean, we will get into a whole acid unit later on, and one of the big things we do say is acids are things that we do generally consume, okay? There are lots of acids that we consume. Obviously, we do not consume car battery acid, do not, okay? But they do have this sour taste to them, and that's going to be one of the big qualities we give to acids, okay? So here we go. How do we write the acidic compound chemical formula? So we're going to go from name, well, we're not even starting with the name. We're going to go, if I give you the two elements, how do we make it, how do we write out the acid formula? So the nice thing is it's a continuation of the ionic chemical formulas, the way we've done it. We need the overall charge of the compound to be neutral, okay? You will be putting two ions together. It's just one of them is hydrogen, and one of them's always, that means it's always +1. So we should be able to balance the charges pretty easily. If the charge of the anion is greater than 1, you just need more hydrogens. That's all we need to do. So we can still use this CDR method, but to be honest, you just match up what the charge of the anion is, and that's the number of hydrogens you need. All right? So, for example, it says, write the chemical formula for the acid containing hydrogen and nitrogen. So what we do is we have hydrogen as H+, and we have nitrogen as -3. So what do? We crisscross those. You can do that, like I said, very easily. So we have H3N, and that is my compound name. Or as I said, whatever the anion charge is, that's the number of hydrogens you need, and then you write the other ion. You're only going to ever need one of the anion, okay? But H3N. All right, next one, hydrogen and bromine. It's going to get very repetitive. So HBr and Br, bromine is minus. Well, this one's just 1-to-1, so this is just HBr. Okay? We really don't even shouldn't have to do any reducing at all if you do this right. H and phosphorus, plus -3, crisscross, H3P. All right? Again, going pretty quickly because I feel like we've already gone over ionic compounds. You're just crisscrossing the charges involved. Okay? Now, the harder part would be when we eventually get to the naming of it. This is kind of straightforward where I'm giving you the ions. So you have H+ and SO4 -2. So we crisscross again. H2, SO4. All right, I'm moving on from that. I mean, this should be H3PO3. Okay? This will be HCN. So you can check those if you want at another time. All right, how about naming? So this is the part where we do have some differences from ionic compounds, and we got to be very, very careful with this. We basically have two branches of acidic compounds, and that's what we need to pay attention to, is what type of acidic compound do I have, and then each one has its own rules to follow. So there are 2 naming rules. So we're starting off with what we're just going to call binary acids, okay? Binary acids or non-oxy acids. Now there's only like one exception to that, okay? And I'll show you that one non-oxy acid, a tertiary or ternary non-oxy acid. We'll get to that one in a moment. But for what is an oxy acid, first off, you'll see this later as well. An oxy acid is going to be one where you have a polyatomic that has oxygen in it. So we're not going to have any polyatomics in these except for one exception. One exception. Most of these is hydrogen and an element off the periodic table. So if it's just hydrogen and an element off the periodic table, the keys are we have to use the prefix hydro. Now, I know some people sit there and go, well, hydro means hydrogen. Okay, but in our sense, what I want to make you think hydro means is it means periodic table. It means look at the periodic table. Look at the periodic table. Because the other element that's following this prefix hydro is off of the periodic table. All right? It's the word acid that tells you you're going to start with hydrogen and then something else. But hydro will say, grab that other element off the periodic table. So, sorry, let's kind of get, so hydro means look at the periodic table, and then after hydro, you will have the root of the anion element, but you're going to change it to ic at the end, the suffix ic at the end. So it's going to be something, hydro something ic acid. Hydro something ic acid. And then that something is coming off the periodic table. So if I have H2S, so H2S, what I got here is I look at the second element. The H just means this is acid. That's what the H means. That's what always the H is going to mean. As it begins with H, I'm ending with the word acid. I only have a single element here, not a polyatomic. Okay? Or a polyatomic with oxygen, an oxyacid. It's sulfur. All right? So I need to change sulfur, and I need to add the suffix ic. Now, sulfur is one of those unique ones where we do just add the, oops, sorry, shoot. Well, yeah, okay. Sulfuric is what we're going to have. I forgot. I should have said this. It's a single element off the periodic table. I need to start with hydro. So I have hydro at the beginning, acid at the end. It's acid because it starts with hydrogen. It's hydro because it has just one other element. Then I'm going to fill in here with sulfuric. So the full acid term is hydrosulfuric acid. I'll do better next time. Here we go. Let's do better on this one. HI. HI. All right. H, acid. It's just a single element, not a polyatomic. Okay? That means I start with hydro. Then I look at I. I is iodine. Now, this is what we do most of the time, other than like sulfur and phosphorus. Iodine, we do change the ending. We change it to iodic acid. Hydroiodic acid. Okay? So there you go. I bring hydro down because it's a single element. I bring acid down because it's hydrogen. And I change that anion to ic. All right? Here we go. This is the mean one. This is one where I'm going to put a star next to. This is the only polyatomic that follows the hydro rules. Okay, so this is the only one you got to be careful of. All the other ones are oxyacids. This is the only non-oxyacid polyatomic. So I can still follow acid, but because there's no oxygen in that, I do begin this one with hydro. This is the only one like that. I know it's frustrating, but it's the only one. All right. Cn minus is cyanide, so we're going to change this to cyanic. So this is hydrocyanic acid. Okay? Star, star, star. This is the only polyatomic that has hydro at the beginning. HF, last one we'll do. Okay? H, acid, single element, hydro. That's fluorine. I get rid of ene and I change it to ic, hydrofluoric acid. This would be hydrophosphoric acid. So I will point out sulfur does become sulfuric and phosphorus becomes phosphoric. Those are the only two that I can think of. I guess selenium, but we don't run into too much selenic. Okay. All the halogens we cut off. Fluoric, chloric, bromic, iodic. Nitrogen we cut off. We change that to nitric. So these are the only ones we kind of just add ic to the end of it. Okay. All right. Well, what about oxyacids? So what if we actually have an acid, so it starts with hydrogen, but it contains oxygen in it as well. That is called oxyacid. Okay. What we will do here, okay, is this means you have the polyatomic. Okay, I'm going to start at the end. We know it's going to start with H, so it's going to end with the word acid. Okay, so H means acid, not hydro. H means acid. Because the polyatomics are not on the periodic table, they're on their own polyatomic sheet. If you're looking at the polyatomic sheet, we go straight to the root of the oxyanion. There is no hydro prefix. Okay, no hydro prefix with these. So if you don't see hydro, you need to look on your polyatomic sheet. Now the rule you need to remember is the polyatomic, you read the polyatomic name. If it ends with ate, it goes to ic. If it ends with ite, it goes to us. So a lot of times I tell my students at the top of their test, write ate, ic, ite, us. Ate, ic, ite, us. Ate, ic, ite, us. And hopefully you can remember which ending you have for it. And that'll also, again, help you identify which polyatomic it is when I give you the name and you have to go back and write the formula. So, H3PO4. H, that means it's acid. PO4, that's not off the periodic table, that's a polyatomic, so I'm not going to use hydro. I would look up what PO4 is. PO4 is phosphate. 8 to ic. Now, here's the only kind of annoying thing. It's not phosphic. We do, just like I said before, phosphorus, we go back and kind of create the whole name. Phosphoric acid is the name. Phosphoric. If you write phosphic, it is incorrect. All right. So now they're giving us the other one, H3PO3. H means acid. PO3. PO3 is phosphite. Ite changes to us. So this is phosphorus acid. You did it. Okay, A to ic, I to us. All right, this one right here, HNO3. Again, oxyacid has O. Oh, not the O. Okay, the H means acid. Nitrate. Polyatomic, nitrate, 8 to ic. So this would be nitric acid. This one right here, HNO2. See, I'm getting a little tired of these. H is acid, NO2 is nitrite. Ite to us. This is nitrous acid. Nitrous. We don't say truce. Okay, I'm trying to overpronounce the us. Okay, is what we're looking at there. All right, I'll do this one just because you might see, like, you don't change. That was one of the other notes, is we don't take off any of the prefixes or anything on the polyatomic itself. So HClO. So H is acid. ClO is known as hypochlorite. Hypochlorite. All right, I change ite to us, and I keep the rest of the name. So hypochlorous acid. All right, this one would be perchloric acid. This one's going to be sulfuric acid. This one's going to be sulfurous acid. All right, so one of the things I do want to point out that this does not show as much, okay, you got to be careful with, is you will not be just given the two elements and saying put these together. You will be given something like, I mean, I'll do one of the last examples there, sulfuric acid. Okay, and I'll say you need to write the name for this. So you go sulfuric acid. Acid means H, so you should be writing H on that line. Okay, then you go sulfuric. I don't see hydro. No hydro means polyatomic. So you need to go to your polyatomic sheet and you need to go, sulfuric. Ic comes from 8. Is there sulfurate? No, there's no sulfurate, but there's sulfate. And sulfate is SO4 minus 2. All right, you can then do the crisscross, that's fine. But you, as I've been saying, whatever the charge of the anion is the number of hydrogens you need, and then you just write in the anion, H2SO4. If I gave you hydro, I'll go and do selenic. Selenic acid. Hydroselenic acid. Acid, H. Okay? If I don't see an H at the beginning of an acid, I don't know what you're doing. Okay? Acid means H. I have the prefix hydro. That means not hydrogen. It means go to the periodic table. Find this on the periodic table. What looks like selenic? That's selenium. Selenium is Se, and it's minus 2. So we're going to crisscross that on down. So this will be H2Se, and that is your formula. So you need to take the time to really go, is there hydro or not? If there's hydro, periodic table. If there's not, polyatomic. If it's a polyatomic, is it 8 or ite? 8 to ic, ite to us. Hydrogen is at the beginning because all acids start off with hydrogen, H+. All right, thank you very much.